One of the main issues of using video physics to analyze videos, in contrast to Logger Pro, is I can't do much with my time scale. So for instance, video physics will start analyzing your data. For instance, if I drag my video forward and this is where I start analyzing, it's going to start analyzing at 10 minutes and 96 seconds or whatever this time scale is here that occurs as part of the original video itself. This can screw up especially your y-intercept when analyzing these videos. So to show you that, if I slide over to the graphical app, I have ported that data from video physics into my graphical app, and I see that this quadratic function has given me a y-intercept of 54 units, in this case 54 meters. Well, I know my object didn't start at 54 meters. That's a consequence of the time scale being shifted to 10.5 seconds, where I actually started analyzing the video. So how do we get around this? You have two options. Essentially, you can email your original video and video file over to your computer where you have Logger Pro and analyze it there, where there's an option to start collecting at time 0, or in other words, redefine 0 seconds in your video. Or you can use a calculator instead. So what I've done is I've moved over and taken a look at my data in the data table, and I pulled up a calculator emulator. This would work whether it's a TI-83, 84, 86, should work more or less the same way. And what I need to do is make sure that my stat plot is on. So I hit second function y equals, and I'm going to scroll down and hit enter for stat plot 1. I'm going to change that to on. I want to make sure the type is a scatter plot, which is selected. And it's automatically going to plot x values as list 1 and y values as list 2. And I can customize how I want these marks to show up. If I go back to that home screen and I hit stat now and enter on edit, it brings me to lists of values. So in this case, what I'm going to do is I'm manually going to shift my time values down 10.48 seconds. So I'm almost done inputting my values. I just need to put the last one in. And you might be saying this takes a long time, but it actually doesn't, particularly if back in the video analysis step I'm taking care to make sure that I'm recording data points at equal frame values. Okay, so now that I've got my last point in for my time, these are all shifted by 10.48 seconds, so that my first time point is at 0, and so on from there. I input my original dependent variable, which is we're calling x, or position in the x direction. So I just have to input those values now, and I do that by hitting enter to register that I'm in list 2, and now I start inputting those values. So I'm going to only go to the ½ centimeter level of precision here. And so I'm almost done inputting my data. Got to put that last point in, 1.461. Okay, and now I can go ahead and hit graph. And if I zoom in just a little bit, I can see that this graph appears to be some sort of quadratic function. So if I'm pretty confident in my choice, I can either go back and linearize this quote unquote by hand and have the calculator calculate squared values for my t-axis. Or what I can do is I can just go back to stat, hit calculate, and go down to the quadratic regression. If I hit enter there and enter again, it's going to use my two lists. L1 is going to be my t-values, L2 is going to be my my position values. And here I get the coefficients of my y equals ax squared plus bx plus c. Notice before I had a y-intercept of about 50, now I have a y-intercept of, or a vertical intercept rather, of 8 times 10 to the negative fourth. Functionally, that's 0. And I can run statistics on all of this, find out what the RMSE is and the correlation as well. But this will suffice for me at this point. So that's how you're able to get around the lack of functionality in the video physics and graphical apps and adjust your t-values on your calculator. Even if you don't have an iPad, this is a useful skill as you'll be able to take your calculator into any exam with you.